So the second assumption for parametric data is the homogeneity of variance. This means that the variance of your outcome variable, like scores on a test, for example, should be the same in each group, males and females, or Sussex and Dunstone. Um, I will explain the homogeneity of variance based on an example taken from Andy Field's book, Discovering Statistics Using SPSS. So imagine that an audiologist was interested in the effects of loud concerts on people's hearing. So, in order to find out whether these loud concerts have any effect on people's hearing, she sent 10 people on tour with the loudest band he could find or she could find, which was the Motorhead. So, these people went to concerts in Brixton, London, Brighton, Bristol, Edinburgh, Newcastle, Cardiff, and Dublin. After each concert, the audiologist measured the number of hours after the concert that these people had ringing in their ears. So here you can see the number of hours these people had ringing in their ears from 0 to 50. And as you can see, um, the means are indicated in both graphs. So these circles are the people themselves, so a 5 person in each group. And the means are indicated in both graphs. And you can see in both graphs that the number of hours these people experienced ringing for has increased. So there is a cumulative effect. After the Brixton concert, here for example, people experienced on average 12 hours of ringing, while after the last concert, the Dublin concert, people experienced on average 45 uh, hours of ringing in the ears. So this pattern is found in both graphs. The difference is in terms of the spread of the scores around the mean. If you look at the left side, the spread of scores stays the same after each concert. So the difference between the lowest and the highest score is almost the same, very similar, and this is what we call homogeneity of variance. That is, the outcome is the same in each group, so after each concert. Although on the left or on the right hand side, you can see that the spread of scores around the mean is different at each level, which violates the homogeneity of variance, and we call this heterogeneity of variance. So it means that this data is not normally distributed. We can quantify the homogeneity of variance in SPSS by looking at the Levene's test, and the result of the Levene's test should be bigger than 0.05. It is the same assumption in terms of number as the Kolmogorov-Smirnov, so it should be bigger, it should be non-significant. So in order to show you how it works, we will try in SPSS. So we use the same data set as before, SPSS exam. You should remember the study. So here there were 4 dependent variable: percentage on SPSS exam, students' computer literacy, the percentage of lectures the students attended, their numeracy ability on a scale from 0 to 15, and they were taken from 2 universities, Dunstone and Sussex. So to check Levene's test, we go to descriptive statistics, explore. Remember that here again we compare two different groups, so we would like to see whether homogeneity is this of variance is the same in all groups. So again, let's say percentage and numeracy as before, and university will be our factor. Here everything is set well. And then remember that in plots, previously we checked for normality, Kolmogorov, Smirnov and Shapiro-Wilk, and now we check the spread versus level with Levene test, and you have to click on untransformed because we would like to calculate the homogeneity of variance for the raw data. Continue and click OK. Takes time. You can see the descriptive statistics for both universities on percentage of on SPSS exam and Sussex. Again, you can see that the Sussex did much better than Dunstan University on numeracy as well. Okay, and here you can see the test of homogeneity of variance. You always look at the line based on mean and you look at the significance. So the significance should be bigger than 0.05. In the case of percentage on SPSS, this assumption is met. So we can say that the percentage on SPSS exam variable is normally distributed. While looking at the numeracy, you can see that this is smaller than 0.05, so the homogeneity of variance in the variable of numeracy is violated. So this data is non-normal, so there is non-normality, which confirms the Kolmogorov-Smirnov test, the histogram test, and all the tests that we ran before. So this is not too difficult, right? That's it.